Right, okay, so this is the paper 2 mock, and it's a calculator paper, so I'm just getting the calculator up on the screen here. I shall clear that. Here we go. Right, so circle the fraction that is equivalent to 3.875. Well, some calculators I could just type in a decimal and convert it to a fraction straight away. This one's not quite like that. So instead, what I'm going to do is I'm going to have this as 3.875 divided by, this is the equivalent of 3.875 divided by, now I'm moving this decimal point 1 to 3 times, multiplying this by 1,000. So I must multiply the bottom by 1,000. Compensate. So I'm going to have 3.875 as a fraction with 1,000. Now your calculator would have make this look nice. It would have a proper fraction. It is 31/8. There we are. So it's pure calculator work, really. What is 50 as a percentage of 20? Is the next question. Well, we can see that 50 is 2.5 times bigger than 20, so that's going to be 250%. Circle the point that does not lie on the curve y equals x cubed. Right, so we need to know that if we take the x coordinates, so that's these things here, we need to make sure the ones that do lie on the curve is by calculating the cube of the x coordinates. So we need to cube each one of the x coordinates. So the cube of -1/2 is, if we cube that, well, 1 cubed is 1, so that's correct. 2 cubed is 8, so that's correct. And then minus cubed is a minus times a minus times a minus, which is also a minus. So this one is actually does lie on the curve. 5 cubed is indeed 125, so this one's okay. 1/3 cubed, well, 1 cubed is 1, the numerator's all right, but 3 cubed is 27, so this is the one that doesn't lie on the curve. Just to check for certain, -1 cubed is -1 times -1 times -1, which is -1, so that one's okay as well. Question 4. Which one of these is a unit of density? So what is density? You need to remember that. Density is the amount of stuff that you have, in other words, how many kilograms, if you like, or its mass, divided by its volume. Okay, so you can remember mass divided by volume. So what are the units of mass divided by volume? Well, mass is usually kilograms, and volumes is meters cubed. So kilograms per meter cubed. Kilogram per meter cubed. There it is, right there. Now we need to solve this equation. So we've got x's in 2 places here. So the first thing we need to do is to gather all the x's together. So we're going to multiply out the brackets first. So 4 times 3x is 12x. 4 times -2, remember that minus is -8. So that's 2x minus 5. And we want to get the x's together, so we're going to subtract 2x from both sides. So here we're going to subtract 2x from 12x, giving 10x. And now we're going to add 8 to both sides to remove the numbers. So we're going to add 8 to both sides. -5 add 8 is 3. And then we're going to divide both sides by 10. So we get 3/10. Fraction is fine there. It'd be okay if you put a decimal as well, but a fraction is better. Okay. Next question, question 6. graph shows information about prisms with the same volume. Right, okay, so this is about prisms with the same volume. Give one example to show the volume is 24 centimeters cubed. Right, so we need the volume to be 24 centimeter cubed. Now, the first thing you need to remember with this question, that the volume of a prism is the area of cross-section multiplied by, I beg your pardon, by the length. So, for example, if you've got a cylinder, this is the area of the cross-section, which is a circle, and the length of the cylinder would be this length, L here, and other types of prisms. Remember, a prism has a constant cross-section, so if I slice this always, I'm going to get a circle. Doesn't matter where I slice it, we'll always get a circle. So we need the volume, so we want the cross-section multiplied together with the length to give 24. So we could basically pick maybe a factor of 24, maybe 6, for example. And so if we go to 6, we go, across, so we want that accurate here. Obviously, we do that with a rule. And 6 times 4 is indeed 24. So here we would have 6 times 24. And we can say on graph. So we've shown that on the graph. Oh, sorry, 6 times 4, I beg your pardon, which is 24. And the units are centimeters cubed. Next question, 6b. The diagram shows a prism with volume 24 centimeters cubed. The height of the triangular cross-section is h. Work out the height h. So again, we know that the volume is the area of cross-section. So the area of cross-section multiplied by the length. Okay, and we are told that that's 24, so we're going to equal 24. So this is basically the equation that we're going to solve here. Let's work out the area of the cross-section. Remember, the area of the cross-section is, this is a triangle, and a triangle has, assuming that we get a right angle, is the half of the base multiplied by the height. And the base is this 6, so this is a half of the base times the height. And then we're going to multiply that by the length, which is 5 centimeters. And we're told that that's 24. Okay, so our idea now is to work out what h is. Well, 6 over 2 is 3. 3 5s are 15, so that's 15h is 24. So h is 24 over 15. Now, it doesn't tell us to write that in terms of a fraction or a decimal, but at least I suppose we could write that in its simplest form, which is of course 8/5, because 3 goes into both 24 and 15. A decimal would be fine, but we prefer fractions. Question 7. Describe fully the single transformation that maps triangle A to triangle B. Now we should see that this is an enlargement here, so we need to draw an enlargement. So what we're going to do is we're going to draw lines that go through both shapes on the edges, like so. Difficult to get this exactly right on the computer. It wants to jump. I could change that, but and we're going to do the same thing here. Some people call these the perspective lines. There we are. Okay. Now I think these are actually, this line that I just drew is not quite right. That should go, see there's a missing here. So actually it should go through that point there. Look like that. So my center of enlargement is this point here, which is 5, 1. So this is an enlargement By the way, notice that there's 3 marks here, so they're looking for the word enlargement. They're looking for by how much are we enlarging. So we're going from triangle A, which is bigger, to a smaller triangle. So that means that the scale of enlargement is less than 1. So if we look at the length of this line, for example, this is of length 2 from 4 to 6, and this is of length 2, 4, 6. It is a third as big. Okay, so in an enlargement, and it's about this point, about the point, and the point is 5, 1, and with a scale factor. And this is where people get caught out. It's going from A to B, so it's less than 1. So instead of it being 3, B is a third as big as A. So your 3 marks on the enlargement, 0.51, and the scale factor of a third. Question 8. The table shows information about distances walked by 120 students on their way to school 1 week. Work out an estimate for the mean. The first thing is that estimate should tell you something. It tells us that we need to estimate the distances somehow. And for calculating the mean, we need to use the mid-class value. So we're going to put another mid-class value, and that's how x is here. So we need to go halfway between 0 and 5, which of course is 2.5, halfway between 5 and 10, which is 7.5, halfway between 10 and 15, 12.5, and halfway between 15 and 20, which is 17.5. So they're the values of x. These are the approximations that we're going to use for these, because we don't know the exact values of x. We only know that the x's are in this range. Now for the mean, what we need to calculate is the x's times the frequency. So this is xf, and what we mean x, we mean this x here. So this is 2.5 times 20. Okay, so 2.5 times 20, obviously we could do that in our heads if we wanted to, which is 50. 7.5 times 4.8, 7.5 times 4.8, 36. And now 12.5 times 30, 12.5 times 30, 375. And now 17.5 times 22, 17.5 times 22, that's 385. Okay, now the mean, which we write x bar, is all of the xf's added together divided by the sum of the frequencies. You need to remember that. Okay, remember that. Sum of the xf's is this total here. Notice they give us a nice total column there. So that's 385 plus 375 plus 36 plus 50. That's 846. Divided by the sum of f. They tell us what that is. It's 120, which is there. Okay, so we've got 846 divided by 120. If you want it as a decimal, and it's 7.05 miles. Question 9. Work out the size of angle x. Okay, we're trying to work out an angle. We have got a right angle triangle, so we are allowed to use SOHCAHTOA. Is only for right angle triangles. Don't try using SOHCAHTOA for non-right angle triangles. If we're concentrating on that angle x with our eye and looking over the triangle, we can see that the opposite is this. The opposite of angle x is this side, and this is adjacent to the angle. So this is adjacent here. So we're involving the opposite and the adjacent. So opposites, tick those. Adjacents, tick those. As soon as we get 2 ticks above one set of 3, that gives us our ratio. This stands for the tangent of the angle is equal to opposite over adjacent. We should never write tan on its own. Tan doesn't mean anything on its own unless you've got an angle here. So how do I work out x? We do the inverse tangent. Okay, so I'm just going to check that this calculator is in degrees. Let's just check that. No, my angles are not in degrees at the moment. I'm going to change that in degrees now. So I'm going to do inverse tangent. Again, on your calculator, it might look very slightly different. You probably want to use the fraction button there. And we get 23, and we're going to do 3 significant figures here. 23.2. 3 significant figures. And I always recommend you write down, put in brackets, what accuracy you're using. Quite often the questions will tell you what accuracy you need. If not, you should go with what it says at the front. If it doesn't say anything at the front, then you should put something suitable, and to describe to the examiner what accuracy you've used, put it in brackets. Usually 3 significant figures is a good idea, as it's obvious that 3 significant figures is not appropriate. Okay, quadratic sequence now. Work out the next term of the quadratic sequence. So how do we do that? Well, we should notice that this first difference between 5 and 8 is obviously 3. This is now going to go up by 6. This then goes up by, look at this carefully, 4 to 6 plus 3, which is 9. So you can see the pattern of the first difference here. This is the first difference. So the next one is going to go up by 12. 3, 6, 9, 12. And therefore this next answer here is going to be 23 plus 12, which is 35. So you don't need a convoluted way of doing that. It's a nice straightforward method. Question 11. Circle the expression that is equivalent to this, which certainly seems as though we have to do some sort of factorization process that's going on here. What is common to numerator and denominator? Well, there aren't any x's there, because of this term here doesn't have any x's. But we could certainly factorize the denominator. 3 is common to both of these terms, so let's take out 3 as a common factor. And what do we multiply 3 with to get 6? Yes, of course, we get 2, so we've got 2x squared here. What do we multiply to get 3? With 3 with to get 3, we get 1. And then we can cancel here. What I do not want to see you doing is cancelling here. Do not do that. If there is a plus in between terms, you do not cancel, only if there are multiplications here. Do not do that. So we've got x squared over 2x squared plus 1. Question 12. Table shows information about the UK and Germany. Population density is population over area. Compare the population densities of the UK and Germany. Okay, so we've got a formula for population density. So let's have a look at the population density for the UK is equal to, well, we want the population of the UK, 6. We've got large numbers here. It might be nice to write this in standard form. 6.4, and if I put my point there, I'm moving the decimal point once, twice, 3 times 4, 5, 6, 7. So this is times 10 to the 7. Might be always worth using scientific notation for large numbers. Divided by the area. Now this is square miles, so that's fine. So we've got 1, 2, 3, 4 times. So this is 9.5 times 10 to the 4. And we can work that out. So what we could do is to simplify that a little bit. 6.4 divided by 9.5 times 10 to the... What do we do with these indices? We subtract them, right? So this is 10 to the 3. So let's have a look at that. 6.4 times 10 to the 3. I'm going to divide that by 9.5. And we're ending up with 673.7. That's one decimal place. I'll put my rounding in brackets. Let's have a look at the population density of Germany. Well, here we've got 8.2 times 10 to the 7. This is roughly the same size, same number of zeros, just slightly bigger population in Germany. And here we've got 1.4 times 10. There we've got one extra, move the decimal point here. 1, 2, 3, 4, 5. Okay, so we're ending up with 8.2 over 1.4 times 10 to the, now 7 minus 5 is 2. So 8.2 times 10 to the 2, which is 100 of course, divided by 1.4. And here we get, these are equal signs, 585.7. So we've done the calculations. We need to compare population densities. So there are a greater number of people per square mile in the UK than there is in Germany. The 673 is bigger than 585, is a greater population density in the UK than in Germany. Okay. It means that basically we're packed in tighter. Germany's got a lot greater population, but it's also got significantly more area in which to pack these people in. Question 13. Two straight lines intersect at the point P. Now, straight lines are y equals 3x and y equals minus 1. Circle the coordinates of P. So this is a little bit like simultaneous equations. So here we've got y equals 3x, y equals minus 1, and I'm going to subtract this. If this is 1, equation 1, this is equation 2. I'm going to do 1 minus 2. 1 minus 2. So y minus y is nothing. And 3x minus 1. Be careful, I'm subtracting 3x minus 1, which is 3x plus 1. So I get 3x plus 1 equals 0. And if I try and solve that, subtract 1 from both sides, I get 3x is minus 1. And I divide both sides by 3, I get x is minus 1/3. And y is minus 1, which we already had. So x is minus 1/3 and y equals minus 1. It must be there. Question 14. Ball is thrown from a height of 15 meters. It bounces to a height h1 here, and then to a height h2. h1 is 3/4 of the original height. Okay, so h1 is 3/4 of, which is times the original height, 15. Jack expects h2 to be 3/4 of h1. Work out the value of h2 that he expects. Okay, well, let's just finish this off a little bit. This is 45 over 4, isn't it? 3, remember that's divided by 1. 3/15, so 45 divided by 4 times y is 4. So what does he expect h2 to be? h2 he expects to be 3/4 of h1. And h1 is 45 over 4. Okay, so we end up with 3/45, which is 135 divided by 4 fours is 16. And we could put that as a decimal if you wanted to. It's 8.4375. You could also put it as a fraction if you wanted to. 135 over 16 doesn't cancel down. I think that would be an acceptable answer. But you might want to write 8.4375 meters, since we'd already calculated that. (14b). It says, in fact, H2 is 2/3 of H1. How does this affect the answer to A? So the answer to A was H2 is 3/4 of H1. But actually what he's saying is it's 2/3. Okay, it's only 2/3. We want to know which is bigger if it was 2/3. So if H2 is actually only 2/3 of 15, then obviously we can cancel down here and we end up with 10. Alright. So H2 is only 10, whereas in the first the expectation was 8.4 something. So it's actually going to be higher than expected. Oh no, this is factual. This is what he expected. So how does it affect the answer? Ball bounced higher than expected. This is the actual. This is expected, so it bounced higher. Yes, that's right. Just getting that right. Show you're working to support your answer. So that's actually this working down here. Question 15. Mirek invests £6,000 at a compound interest rate of 1.5% per year, and he wants to earn more than £1,000 in interest. Work out the least time. As soon as you see things like the least time, or at most, things like that, at least, at most, something like that, we should start thinking about inequalities. Now, for this question as well, we should be thinking about compound interest quite clearly. So, the compound interest formula that you should know is the principal value, which is how much is invested, times 1 plus the rate divided by 100 raised to the power n. Okay, and n is the number of years. Okay, and we actually want that compound interest to be more than £1,000, so we want that to be greater than 1,000. Let's put the numbers in. P is £6,000 to start. And we've got 1 plus the rate, 1.5 over 100, and to the n is greater than 1,000. Okay. Now, what we could do here, if you were an A level, you could answer this with something called logarithms. But in the case of GCSE, we're just going to test this out to see which one works. So let's try different values. Let's try n equals 2 and see what happens. So we're going to have 6,000 times 1 plus 1.5 divided by 100. We're going to raise that to the power 2, and that's 6,000 times 1.5 divided by 100, all raised to the power 2. That's 6,181, so that's only £181 in interest. Okay. Actually, so we want this to be greater than 7,000, don't we, to make sure that that works. So let's go back and say instead of 2, let's try perhaps 5. See what happens there. That's still not enough, so we'll go back again. Try 8 perhaps. Still not quite enough. Go back again. Maybe 10 years. Still not quite enough. So we've got to start getting a bit more careful now. Let's try 11. Oops, I did 111 years. Yeah, can you see that's now changed over to being greater than 7,000? So it's earned more than £1,000. So start with 6,000. Now I've got 7,067. So The least time we want is 11 years. 11 years. And the reason being is because 6,001 plus 1.5 over 100 to the 11 is 7,067.69. And if we did that to 10, back again, that's 6,000. So 6,000 plus 1.5 over 100 to the 10 is 6,963. That's not enough. Too little. So the answer is 11. Okay, so I'll just get a rough idea about how to do that with the calculator. Question 16. Factorize fully. Right, so we need to be thinking about what's common to both of these. Let's do numbers first. What's common to 9 and 6? Well, that's clearly 3. 3 is common, and what's in letters? What's common here? Y and y cubed. Y is common. So what do I multiply 3y with to get 9y cubed? Well, obviously 3 times 3 gives us the 9, and y times y squared gives me the y cubed. And then I subtract, and then now I've got 2 here. Because 3y times minus 2 is minus 6y. Now we're going to factorize a quadratic. Right, so notice that this, because of this term here, is plus 7, we can't take x out as a common factor, so indeed we're going to actually need 2 brackets. Now, this is one of the harder ones. Here we've got 3x squared, so here we're going to have 3x and x. It can't be anything other than 3x and x, except that you could swap the positions around, because 3 is a prime number, so 3 only factorizes into 3 and 1, so that's 3x squared. Now 7 is also prime, that's nice, so that means this must be 7 and 1 placed here. And I'm trying to combine the 7 and 1 to get minus 22. So hopefully you can see by putting a 7 there, and if I imagine foiling these out, so when I foil, it's like this crab claw, that 3 times the 7 gives me 21, and this one will give me a 1, 21 and 1 will give me this 22. Both of them need to be negative. Remember, a minus times a minus is a plus, so if this sign is the same, if this sign is a plus here, then this one here, which it is, then these signs must be the same, either minus or plus plus. But in order to get a minus here, they must both be minus. So that's that factorized. Okay, so that's my answer. I could place that back in here if I wanted to. Next question. Work out the area of the parallelogram. Right, now a parallelogram, how do we work out the area of a parallelogram? Well, what we actually need is the perpendicular distance between them. Let's call that h, because the area of a parallelogram, and also a rhombus and things like that, is half of the sum of the parallel sides times the perpendicular distance between them, which we're calling h. So we need to find out what that h is. So that's one way of doing it. Problem with that is that we don't know this distance. Okay, so there is another way that we can do this question, and that is by splitting this into 2 equal triangles. Remember, this is a parallelogram, so this is 16 here and this is 12 here. So these are identical triangles. So therefore, the better way to do this question is to do that two-triangle trick. So our area A, so let's call this area A, is, remember, this is a non-right angle triangle, so we don't use half base times height, we use a half AB sine C. This is my angle C here, and my A and B live here. So this is a half times A, which is 12, times B, which is 16, times the sine of 72. So my total area is twice that, so this half will cancel. So this is 12 times 16 times the sine of 72. So we'll put that in the calculator, 12 times 16 times the sine of 72. And we're left with 182.6, 182.6. And this time we're using one decimal place, 183 to one significant figure if we prefer. Question 18. Which of these represents the shaded region? Right, okay, so notice that the shaded region is this sort of crescent moon here. So it's got to involve sort of A to a certain extent. If we shaded everything outside of B, so let's just do that. Everything outside of B, that's not B. Yeah, what I'm shading now is not B. Okay, so this shading here is not B. Okay, and you can see that A, this is A. If I shaded all of A, shade that with perhaps the green. Okay, so this green is A, and the dark blue shading is not B. We can see that the bit that's actually shaded, which is this bit here, is where the blue crossing shading intersects with the green. Remember, the green was A, the crossing was not B, so it is the intersection of A and not B. Right, 18b, if you remember that inside these white circles, this is the union. So if we're talking about this shape here, this is the union. Okay, so maybe show that in for you. So this shading inside here is A union B. What is shaded is exactly not that. It's not that green thing. So we simply not the A union B. So what's shaded is not of A union B. Question 19. The length of a rectangle is 5 times the width. Well, we don't know what the width is and we don't know what the length is. So what do we do in questions we don't know something? Give it a letter. Okay, so let's say this width is x. The length is 5 times the width. So this is 5x here. So we might say something like, let the width equal x and the length is 5x. The area of the rectangle, so what's the formula for an area of a rectangle? Well, it is length times breadth, or length times width. So that is the width, x, times the length, 5x. And we're told that the area is 1620. So we've got this equation now. Multiply these together, 5x times x is 5x squared, 1620. Divide both sides by 5. So x is, remember when we square root we do plus or minus. But we don't want x to be negative because x is a width. So we're going to ignore the negative. So ignore negative. But get into the habit of doing plus or minus. Now we're going to use our calculator. So we want the square root, and again your calculator will be nicer to do this as a nice fraction. And we're left with 18 centimeters. Question 20. A stone is thrown upwards with a speed of v meters per second, and the stone reaches a maximum height of h. H is directly proportional to v squared. Okay, we're starting to think about proportionality now. When you think about proportionality, you should follow the steps that we did in class. So step 1, to write a proportionality statement. H is directly proportional to v squared. And what do we do for step 2? We introduce a constant proportionality. So H equals k v squared. Step 3 is we use some information to find k. We're told this information here. So when v equals 10, h is 5. So h is 5. K we don't know yet. V is 10. So v squared is 100. Divide both sides by 100. So k is 5 100ths. Okay? And 5 100ths, of course, is the same as 1/20th, if we prefer. The next step, step 4, is to substitute this value k back into this equation here. So h is, could just leave it as 500ths if we prefer, times v squared. Okay, so just replacing this value of k with its real value here. Work out the maximum height reached when v equals 24. So now we're just going to, step 5 is to answer the question. So when v equals 24, we're going to substitute this 24 into there. H is 5 over 100 times 24 squared. Put that in the calculator. 5 divided by 100 times 24 squared. 28.8. Yes.